Welcome everyone. So we'll be talking about white wine flavor compounds today, what they smell like and what their origins are in wine. So my name is Sietse Wijma. I'm the founder of the Art of Tasting. I give classes using wines with added aromatic compounds, and I'll be using some of my samples to guide us through the tasting today for the presentation. I have a Master of Sensory Science, which is the study of flavor perception. So this is where you learn about the senses of smell and taste. I have my level 4 diploma in wines from the Wine and Spirit Education Trust. And I'm also an advanced Cicerone. So this is the beer equivalent of a sommelier. The PowerPoint slides will be made available for this presentation. So I will share you a link at the end of the presentation if you want to access these. And if you're joining us with the tasting kit, now this presentation can be attended both without samples as well as with samples. And there's two options. Either you have the tasting kit, which have the samples that look like this, and it's wines with the aromatic compounds pre-added. So it's just a case of pouring that into your glass like this, which we'll do with the first 3 bottles. So that's the reference wine, and that is the glasses number 1 and glasses number 2. But maybe you're also joining us with the flavoring vials, which look like this. They come with a pipette, so you can simply squeeze the pipette, open the vial, and then use the pipette to make additions to your own wines. So to your own neutral wine that you've chosen to use for this particular exercise. With that out of the way, let's talk about aromatic compounds. And so I first started as working in a wine store, and I remember this customer coming to me with a bottle, and on the label it said has green bell pepper aromas. They were worried because they were allergic to bell peppers. So I reassured them, no, there's no actual allergens in the wine bottle. But it does raise the question of what actually is the similarity between wine and bell peppers if you look at it from a chemical perspective. And indeed, there is a similarity. Now, I want to illustrate a principle to you, and that is that all aromas in our daily lives consist of multiple aromatic compounds. Now, another way to call compounds are molecules. So these are the chemical structures that are present in something like a green bell pepper. And these are small compounds that are light enough to escape from the bell pepper and that are being detected by our nose as having a certain scent. And the combination of that reminds us of green bell pepper. Now, the same is true for wine, which is illustrated over here. So yes, dozens of compounds that together make the unique impression of that particular glass of wine. This is just not unique to these 2 products, but also something like lavender or tea or coffee, chocolate, you name it. It always consists of different compounds. And interestingly, look at this. There's one of them that they have in common, which means that this is an aroma. The aroma of this wine will remind us of that green bell pepper because there is that chemical overlap, okay? And that is the principle behind this presentation, where we will talk about 10 of these examples. So 10 compounds that are found both in wine and in other sources that will draw that reminiscence, if that makes sense. Now let's move on to the first glass, which indeed smells of a green bell pepper. Now the base wine for these samples are all the same. So it's 11 glasses of the same base wine, except that there's an aroma addition to the numbered glasses 1 through to 10. And the reference glass is the wine with no aroma addition. So that can serve as a point of comparison, okay? Green bell pepper is the most common descriptor of this particular glass. So what this graph shows you is a group of wine tasters. These are about 20 tasters, which I've asked, tell me what this glass smells like. And then you see the majority of the tasters saying, that smells like a green bell pepper to me. But there's also a sizable portion of that group who says, I can smell tomato leaves. And I think that makes a lot of sense. The green parts of the tomato plants, so the stems and the leaves, it's almost like you're walking into a greenhouse. It has that same smell. Asparagus, green asparagus in specific can smell like this. Jalapeno, earthy cut grass, certainly something green about this. Green beans and coffee beans before roasting can also release this particular smell. So no one is particularly right or wrong when they're using these descriptors, just various ways of looking at that same compound. And indeed, we have some scientific evidence to back up that that compound is not only present in wine, but also in bell peppers and all of the other mentioned things here. So it can remind you of various things. That's out of the way. Let's see what it smells like, or how it, excuse me, how it develops in wine. So it develops in the grape itself. This is a so-called primary flavor, and primary flavors are formed either in the grape or during fermentation. And it's specifically the Sauvignon Blanc grapes that produce this. And when they're grown in a somewhat cooler climate with high shady conditions, you're going to get greater levels of the green bell pepper flavor in your compound. Fruit ripeness. If you're harvesting somewhat earlier, you're going to expect greater levels of the green bell pepper flavor versus a later harvest, which has less of the green bell pepper flavor. So it's various factors that impact how much of that compound will be eventually noticeable in your wine. The production steps in the process of winemaking is mentioned here. In bold are the so-called compulsory steps, so they always happen in production. And in italics are the optional steps, so those are what you could call stylistic choices. I've highlighted the step in green, which is most relevant for the compound that we're discussing. So this first sample, the green bell pepper sample, is mostly managed in the vineyard. There's not that much you can do in a winery to control it. So that's mostly about grape reception, grape growing. Chemical structures here, the icon is there. The detection threshold, this is the minimum quantity that must be present of this particular compound in wine before you start to notice it. And the order of ng is short for nanograms, which is a very small quantity. So nanogram is basically a millionth of a milligram. Milligram might be more familiar to you. A sugar granule is an example of something that's give or take a milligram. So a millionth of a sugar granule. These are extremely small quantities, okay? And yeah, it's just very potent aromatic compounds. And that said, let's smell that glass number 2. I have a blank slide here because if you're rewatching this recording later on, this is being recorded and will be uploaded onto my YouTube channel at some point. You have then the option to pause the video and try to work out what the smell of this particular aroma could be. But for now, just to keep the pace of the presentation a bit higher, I'm going to reveal what that is. And that's indeed the smell of elderflower. And it's another sign of Sauvignon Blanc, a compound called 4-MMP, and a very interesting set of descriptors here. So not just that elderflower scent, but there's also something tropical going on here. Passion fruit, very much a suitable descriptor for what you're smelling in this glass. Cat urine, interesting. That's a different take on the same aroma, but honestly, it can remind you of both things if you think about it. Guava, similar to that passion fruit tropical character. Aromas of box tree, gooseberry. This is a type of tea made with cassia seeds. There's also something sweaty about this aroma. So quite interesting how really one specific aroma compound is responsible for all of these different notes in wine. And it is really reflective of what you're most familiar with. Possibly if you live in UK, for example, you might be more familiar with an elderflower cordial, for example, one of those products where elderflower is really noticeable. And if you live more in tropical climates, then passion fruit might resonate with you more. So there's various options there. Now, this is indeed still a compound that we associate with Sauvignon Blanc, but you could say that this is almost the opposite of the green bell pepper smell, as in it has much of a riper style, so it's connected with more of a riper version of Sauvignon Blanc. And it develops later in the ripening cycles of grapes. We also know that increased temperatures as well as sunlight exposure can result in greater levels of this particular flavor, 4-MMP. Now, 4-MMP is not as noticeable in the grapes itself. So suppose you would be tasting Sauvignon Blanc grapes in the vineyard, or you would be pressing juice out of it. That juice doesn't necessarily smell of elderflower, but you need to wait until alcoholic fermentation before this aroma starts to become noticeable, before it is revealed. Because initially, it is what you could say it is trapped in the grape. So it's connected to other components that are present in the grape, and yeast needs to release that. So it needs to sort of cleave between the 4-MMP and the other grape aroma components. and then it starts to become noticeable. Of course, yeast, famous for turning sugar into alcohol, but it does so many other things, so many other conversions, and that release of some of the important aromas in white wine is responsible for some yeast action. Now, what they're very good at that in New Zealand, they will select certain yeast strains that are known to be very efficient at releasing that 4-MMP and related sulfur compounds. It's interesting that this belongs to the class of sulfur compounds. I think sulfur compounds don't necessarily have a good reputation in the wine world. They're often linked to a fault called reduction, which is indeed caused by specific sulfur compounds that can be very unpleasant smelling. Over here is also the molecular structure of this particular compound. So it can be observed that there's indeed an S in there indicating that sulfur. Particularly low detection threshold as well. What I will show you here is putting it into perspective in relation to alcohol. So this is a wine with about 12% alcohol, and the percentage of 4-MMP in there is insanely low, so 0.00, a lot of zeros. And what this really shows is that we are highly sensitive as human beings to certain aromatic compounds, and comparatively not all that sensitive to some of the other aromatic compounds. So that is quite a nice demonstration. Now, for those of you, if you are joining us with the actual samples, you'll have 1 and 2 in front of you, and I'm going to tell you to mix them together and then give that a sniff. So that is the combination of the green bell pepper smell together with the elderflower smell. Very common, especially in New Zealand Sauvignon Blanc. What they would do is some producers harvest part of their grapes earlier to get the most out of that green bell pepper flavor, and the other part of the harvest they will harvest later to get more of that elderflower flavor. And later on, after these grape batches have been vinified, they will mix them together to get the desired style. And that is kind of what you're smelling in this particular sample. So by all means, give that a smell, give that a taste. And then we're going to move on and empty that so that you have 2 empty glasses available for us to move on to the next aromas, 3 and 4. So I'd like you to get out those particular samples, 3 and 4, and go ahead and pour them. Maybe you have everything set up already. That's another great idea, to have the 11 glasses in front of you, allowing for all of the samples that you have received. So that is those 2 pours. I know not all of you have the samples, so I'm just going to crack on and talk about what these aromas smell and taste like. So moving on to glass number 3, which is a very floral scent. Indeed, it is described as rose. There's a compound called geraniol. And let's go through the various descriptors that we have here. Indeed, very rose-like. But other ways of looking at this aroma are bergamot, citronella. There's certainly something very citrusy about it. Not necessarily fresh citrus juice, but more the sort of aromatic kind of citrus. So a citrus peel, for example. That is pretty much the smell you get in your potpourris, this particular flower mixture. And that can indeed remind you of this. Also, there's something woody, sometimes described as sandalwood or pine. That is another way that is of looking at this. It's responsible for some of the stone fruit characters as well. Compound is called geraniol, and this is a good example of a terpene. So terpene is a class of aromatic compounds. When I say class, it means like a family, structurally, related compounds. And those are, the terpenes are mostly responsible for the floral characteristics in wine, both aroma and flavor-wise. And there's a specific set of grape varieties that causes these aromas. And the most famous of those is possibly Muscat, but Gewürztraminer also produces high levels of geraniol. Then there's some aromatic some grape varieties that produce this to a more medium level. Good examples are Riesling and Viognier. So they won't be as noticeable as the Muscat and Gewürztraminer, for example, but still they contribute to the varietal character of those grape varieties. And there's other examples such as Chardonnay or Pinot Blanc that don't produce the flavor compound, the geraniol at all. So those would be considered the more neutral grape varieties. indeed not necessarily noticeable there. In terms of how flavors and aromas distribute between the grape, usually it's not evenly distributed, and you get a greater concentration of that in the skins relatively to the pulp of the grape. So that means that if you apply any skin contact, also known as cold soaking, so you would crush the grapes, but then allow for some contact between the skins and the juice. Doesn't have to be long, can just be under low temperature for a couple of hours. But that is enough to increase the potential geraniol that you're later going to get in your finished wine. This is also an example of an aroma which is partly noticeable in the grape, but part of it is also captured or is trapped in the grape, and you will need some yeast action to release the highest potential geraniol in your wine. And indeed, specific yeast strains have been developed to be very efficient at releasing terpenes. So if you're browsing through a yeast catalog from Lallemand, for example, one of his famous yeast producers, you will find certain strains where it is described as being high geraniol releasers, for example. And winemakers will happily use those strains to get the most out of their muscat. You don't have to, of course. You can also rely on ambient yeast and carry out a spontaneous fermentation. If you're using those types of yeast, you don't really know how efficient they are at releasing the rose aroma from the muscat grapes, and you get more variable levels of this particular compound. Detection threshold is in a range of micrograms. This is in between nanograms and milligrams. These are still very small quantities, but in terms of flavor compounds in general, this is sort of more moderate, or like we're medium sensitive to this particular aromatic compound. Let's move on to number 4, which is related, but distinctly different. This is more of a lychee smell that you're getting here, very tropical, like canned lychees is what it reminds me of in specific. Certainly something floral about it. I hear honeysuckle a lot when I present this aromatic compound to people and ask them what it smells like. Turkish Delight, another great example of a type of sweets that is floral, flavored with floral aromatic compounds. Something soapy about this, like a high quality soap bar, but then the rose descriptor pops up once again. So there's certainly some overlap between what you're smelling in number 3 and number 4. But 4 is more of a specific terpene. We're still in that domain of terpenes, so those causing the floral flavors in wine. And Gewürztraminer is shown to produce the highest levels of this particular compound. It's followed by Muscat, who can produce it at moderate levels, but no other grape varieties have been shown to produce this unique terpene. So geraniol, much more common, and rose oxide is more rare. So that's the compound that is added to wine number 4. The reason that this is called rose oxide is because it was first identified in a study in the 1950s, where they analyzed the aromatic oil of roses, and then they found this in high levels. And oftentimes they name aromatic compounds after their first discovery, so where it was first found in. Doesn't necessarily tell you what it smells like. I think lychee is something that resonates with more people than rose, but that is more of a historic choice that they named it rose oxide. They would, even though they later identified it in lychee, they wouldn't bother to changing the name of the compound, which is fair. So when I was first looking into this topic, I remember this Wikipedia article about Gewürztraminer. Indeed, I've highlighted this particular phrase, which says Gewürztraminer and lychee share the same aroma compounds. And that was my initial realization, where I thought, okay, there's apparently some science to all the aromatic compounds that we, or excuse me, all the aroma descriptors that we use for wine. Apparently, there's some scientific justification for this. And this is referring to a study in the 90s. So it was found later in lychees than it was in roses in the 50s. Anyway, this study looked at various types of lychee, including fresh lychees and tinned lychees, and they found high levels of this compound. They analyzed Gewürztraminer wines as well, and also found high levels. They sourced it from various places in the world, some New World Gewürztraminers, as well as the classic Alsatian Gewürztraminers. They also analyzed Chardonnay and Riesling, and no rose oxide was found in those grape varieties. So interesting finding, especially since Riesling otherwise produces terpenes. So otherwise it produces compounds such as geraniol, as well as linalool, another example of a compound that we are not going to discuss in detail today, but is indeed found in Riesling. So that said, let's move on and create another blend. So we are blending the wines 3 and 4 and give that a smell. And that is a bit more of a realistic impression of what a Gewürztraminer or a Muscat can smell like. So both the rose aroma as well as the lychee aroma. And that is very authentic Gewürztraminer in my view. Let's go ahead and empty this glass. And we will then have made space for the next 2 aromatic compounds. So you have the 2 glasses now. Keep your reference wine so that one stays. You can go back and forth and use that as a point of comparison. So let's pour 5 and 6. And we're going to talk about number 5 first. Okay, number 6. Number 5. Interesting smell, and grape jelly seems to be the most popular descriptor for this compound. Followed by bubblegum. Indeed, it is a type of flavoring you see a lot of in bubblegum. Grape juice as well as grape soda, you hear there's something floral about it. Jasmine appears there, cough syrup, indeed used in those. There's a lot of type of candies that use this flavoring. Jelly Baby is an example of something you see in the UK. New trainers, it has this sort of rubbery flavor, and this is a particular tropical tree. Don't know if anyone's familiar with that smell, but it kind of appears a descriptor. So what are we smelling here? This is a compound called methyl anthranilate, and this is uniquely associated with some grape varieties that have North American DNA in them. So we're looking at the fox grape or the Vitis labrusca. So grape varieties that are not Vitis vinifera, which is the main grape used in the production of wine. The origins of the term fox grape are not entirely clear. So we've used this term for hundreds of years, and there are several theories about it, such as the leaves of the plant that can have this sort of fox-like skin. Some people say that fox is referring to faux, as in F-A-U-X, fox, as in the French term, which would translate to false grape. But also other people say, oh, it smells like a fox. It has this sort of fox breath inside this particular smell. So multiple theories. Anyway, what we know, have known for a long time is that these type of grapes produce certain aromatic compounds that are not found in Vitis vinifera. And we've wondered for some time what it is in terms of the chemistry that causes these aromas. And then methyl anthranilate is a candidate compound. So let's show you the actual study where this was found in. And this is a study which is already carried out a longer time ago. Anyway, it was 7 different wines that was tasted by a tasting panel, and they're listed here. So wines from various varieties: Carlos, Concord, Canada Muscat, and on the bottom you also see some grapes from the Vitis vinifera, Riesling. And they asked the tasting panel, tell me how much foxiness you're getting in these wines. So with foxiness, they meant the characteristic flavors of the Vitis labrusca. So these people that tasted and had a very good idea of what the foxiness was. And indeed, Riesling appears on the bottom. Of course, all of these wines were blind tasted, confirming that indeed there's very little foxiness in that Vitis vinifera. But on top is the Carlos variety, has a lot of North American grape in its DNA and high foxiness rating as a result. They also measured levels of the methyl anthranilate compound. And in some of the grape varieties that were very foxy, they also found high levels of this particular grape jelly smell. And indeed, Riesling doesn't contain any. they confirmed this by presenting also Riesling with some added methyl anthranilate. And then you see also the foxiness rating went up. And in terms of the addition of this particular glass, it's about the same as the addition that they've done in this study. So Niagara, one of those other varieties that have high methyl anthranilate, are also pretty foxy. Importantly, there's also some grapes that are very foxy but have no methyl anthranilate. That tells us that this compound only partly explains what the characteristic flavors are of the non-vitis vinifera grapes. And we don't know exactly what the full flavor profile is. Maybe over the years to come, if there's more research being carried out, we know about some other compounds. Anyway, keep this flavor in mind because peewee grapes, which are the fungus-resistant grape varieties, they are being more and more seen. And those are also the ones that potentially can produce some methyl anthranilate because of that hard DNA of the non-vitis vinifera. Okay, moving on. We're going to number 6. Which is the smell of apple skin. Now, what you might realize about this sample is it is very fruity. It can remind you of apple, but also can remind you of a range of other fruits like pineapple and pear. It's sort of indistinct fruity. And it's also very synthetic and quite artificial. And the other way of looking at it is there's some aniseed character to this. So also explaining licorice and fennel. Sake, and in particular Ginjo sake, has high levels of this particular compound. So what is it called? It is called ethyl hexanoate. And whenever you're smelling something indistinctly fruity, quite synthetic fruit, it means you're looking at a white wine that was produced under a low fermentation temperature. The range of fermentation temperatures is typically between 12 and 22 degrees. But if you're fermenting at 12 degrees, you're forcing yeast to produce higher levels of so-called esters. And esters is the family of flavor molecules to which ethyl hexanoate belongs. Other things we can do. We can select yeast strains known to produce high levels of esters. Juice clarity, another important factor. If you're working with very clear juice, you will have higher levels of those esters. So the more clarification or filtration you do prior to fermentation, the more apple skin and related aromas you're going to get being produced by yeast. In which styles might you come across these? It's typically made or found in those grape varieties that are known to have very high volume production. So those grapes such as Iren, Trebbiano, or Ugni Blanc is the same name for a different name for the same grape. Palangina, those would be considered the sort of workhorse varieties that can produce very high yields. And those wines can indeed be somewhat neutral or almost watery in flavor. But then if you apply this fermentation technique, you're going to get a bit more, at least some fruitiness in your wine. It is maybe not the most complex smell, but I mean, it's not unpleasant. And I can see why people will find some appeal in it in a sort of more higher volume wine styles. Threshold is a bit higher here. So we're looking at 2 milligrams per liter. So we're a bit less sensitive to this particular flavor compared with some of the other compounds. The way that I add these flavors, though, I take that into account. So they're balanced out. And the formulation is 8-fold of the detection threshold. So that means that the added ethyl hexanoate to this sample 6 is about 15 milligrams per liter. Should be fairly noticeable. And I do the same type of addition with the other compounds. So take the detection threshold, multiply by 8, and that's the addition that I do. Should be nice and noticeable. Meanwhile, I'm just checking the chat. If anyone has any questions, of course, feel free to ask them. I will try to keep an eye on them. If not, I can also, at the end of the presentation, review if there's any questions that you would like to ask. Moving on, we are going to get rid of number 5 and 6. No need to blend them. I don't think that these compounds belong together, so no need to blend it. 7 and 8 is what we'll be pouring next. Okay. Okay. Smells of butter. Cookie dough, not a common descriptor, or other various bakery-related products. There's certainly something popcorn-like about this. It used to be very popular flavoring of popcorn. And rice, sometimes spoiled rice can even higher levels of this. So depending on your culture, if butter is something famous in your culture, that's probably what you're smelling, but not everyone consumes butter that regularly. So depends how you're perceiving this compound. And if you're a bit geeky and you know about your flavor compounds, you might already know what the name is of this compound. It's called diacetyl. And diacetyl is a product we associate with the production step malolactic fermentation, which is found after this an optional production step in the production of white wines. And it follows alcoholic fermentation if you choose to let it happen. During malolactic fermentation, we have a fermentation with bacteria, specifically lactic acid bacteria. You might know these because they play a role in yogurt and butter and various dairy-related products. In wine, they convert so-called malic acid into lactic acid. Malic acid is grape-derived, and lactic acid is the product of those bacteria. And the effect of this conversion is a lower acidity. So lactic acid is a much weaker acid than malic, and consequently, if you let this step happen, the wine will typically be a bit softer as a result because of that lack of acidity. That can be a popular choice if you're growing grapes in maybe somewhat cooler climates and the acidity would be too high, and can be too high in those instances. Anyway, a byproduct of that malolactic fermentation is diacetyl. So not only do we produce lactic acid, which only has a taste, lactic acid has no aroma, but diacetyl is the compound that causes some of the aromas that we associate with malolactic fermentation. So, is it always noticeable in malolactic? No, it isn't. So there's various parameters that determine whether you get high levels of this or not. First of all, there are bacterial strains available that you can purchase. Similarly, you have the option of choosing yeast strains. You can also choose your lactic acid bacteria strains. Some of them produce lactic acid, but no diacetyl. Okay, and others are known to produce high diacetyl as well as lactic acid. And that's a way that you can control whether this flavor is apparent in a finished style or not. Diacetyl is also connected with yeast activity, and yeast is known to reduce diacetyl. So whenever after malolactic there's some yeast activity, you will get lower levels of the diacetyl. And a good example of that is lees aging. So if those lees are still active, if they are fine lees, if they're being stirred, especially, they are able to metabolize some of the diacetyl that was produced by the bacteria. Another way that this is relevant is if your alcoholic and malolactic happen at the same time. This is becoming more popular. It is also termed co-inoculation, where you're acting yeast and bacteria, but you're adding them at the same time. Massively speeds up the production process, and as an added effect, you're not going to get any butter flavor in your wine. Still, this is very popular in various Chardonnays. Chardonnay is quite suited to malolactic fermentation because it's quite a neutral grape variety, and it's interesting to use so-called winemaking techniques to get a bit more of an interesting flavor profile in that Chardonnay. Otherwise, it could be a bit neutral and somewhat boring. So butter flavors work quite well. It wouldn't work really well in varieties like Riesling or Sauvignon Blanc, which are prized for their first high acidity, but also fresh flavors, and you wouldn't want any butter flavors, which are a bit more like rich, to sort of detract from that freshness. I've written on premium because this is a step that takes time. It will add up a couple of weeks to your winemaking procedure, and that means that it will take longer until you can start selling the wine. So that is a bit costly. And indeed, a lot of winemakers, when they're producing white wines, they would choose to skip malolactic fermentation, just move on and sell the wine faster. I will also add that butter is a flavor that is getting a little bit out of fashion, I would put it that way. So especially historically, a lot of newer producers would make very buttery Chardonnay, but they're moving away from that and producing more leaner and crisp styles. And there's two reasons for that. The first one is a consumer preference, and the other one is the effect of climate change. So as we're seeing warmer conditions in the vineyards, you're getting lower levels of acidity. And winemakers want to preserve that acidity most of the times. So skipping malolactic then becomes an attractive option because you're then preserving whatever acidity you have, and then you're also not getting the butter flavor. Okay? So very relevant flavor. You see a lot of it in combination with oak as well. Yeah, diacetyl. Let's move on to number 8. Okay. The scent of vanilla, very dominant on the palate as well. May not be immediately obvious on the nose, but is more present on the palate. And that is consistent with when you're tasting real wines as well. So those ones that have no aromatic compounds added. I find it much more reliable if I'm testing for oak to try the wine on the palate and not on the nose. That will give you more reliable indication, in my opinion. Anyway, custard ice cream, these are often flavored with vanilla. So it's a pretty one-dimensional smell. Most people agree on that vanilla. There's certain, I mean, clove, smoky are sort of the nuances that you get when you're smelling this. And whiskey is another descriptor that is relevant. This is a spirit which is always oak-aged. So it makes sense that if you're oak-aging wine, you're going to get some aromatic similarities with whiskey. So indeed, a secondary flavor. Secondary flavors are those as a result of winemaking techniques. So the butter we tried, number 7, is also secondary. Number 8 is a secondary flavor. And we're talking about oak maturation here in specific. Now, this is a pretty simple process. So it's simply pouring the wine into an oak barrel, and then an extraction takes place. So it's the transfer from the vanilla compound, which is called vanillin, from the wood into the wine. Wood itself, so like in the tree, doesn't necessarily smell of vanilla, but this is a product that is formed during cask charring, and I'm just going to show you a picture of what that looks like. So typically, during the production of oak barrels, this is a compulsory step, something that always must happen. You are setting a fire in the inside of a barrel, and that chars the wooden staves that are shown here. It bends them into shape as well, okay? Because originally those staves are straight, but then they're being bent into shape with that fire. This typically lasts for about 45 minutes, say, give or take. And this also generates a lot of the aromas that we associate with oak, including vanilla. So vanilla is more of a product of this toasting process than that it is necessarily something that you find in wood. Some factors here: wood type. We're often categorizing wood into American oak and French oak. Indeed, very useful categorization. You're going to get more vanilla in American oak compared with French oak, but that is true for all oak flavors. So not only vanilla, but also, for example, the smoke or the coffee cloves flavor. You're going to get more of it in American oak. And the reason for that is the structure of American oak is different. It has more of a porous structure. When I say porous, it's almost as if there's tiny air bubbles inside the wood, which is reflective of the growth speed of American oak trees. Growing conditions are warmer in the US, which results in a faster growth of the tree, giving that porous structure. In comparison, in France, you are typically having colder conditions, results in a slower growth of the oak tree with more of a tight or a compact wood as a result. And that type of wood is not going to be very efficient with that extraction process. Okay, so it's not going to release as much vanilla into wine as American oak does. Size, smaller barrels gives you more vanilla and other oak-associated flavors. New oak, more vanilla than older oak. And then the charring process or toasting process, as I mentioned, gives you that vanilla flavor. So also a useful one to mix these together. So number 7 and number 8, let's go ahead and mix them and give that a smell. So that is the malolactic fermentation character of butter together with the oak flavor of vanilla, and these are often seen at the same time. If you're oak aging and you're not blocking malolactic, then it usually will happen in the barrel itself. So butter and oak often seen together, and this is what it smells like. Very much that rich style Chardonnay, which you're smelling here, like a buttery Chardonnay. Okay. We'll get rid of that. She'll leave you with 2 empty glasses. Reference glass is still there. Go ahead and pour number 9 and 10. No, interesting. Connected to the number 8, the vanilla one that we've just described. This is cloves, very spicy. Mulled wine makes sense as a descriptor because cloves are literally added to that wine type. Nutmeg, cinnamon, other spice-associated or related descriptors here that make a lot of sense. Allspice mixture, frequently including one or more of those spices. There's something slightly medicinal about this, and perfume also pops up as a descriptor. I agree, it is a type of aroma that is often used in perfumery, specifically male perfume. This chemically belongs to the same class of aromatic compounds as the vanilla flavor. These both are phenolic compounds. If you're looking at the molecular structure, what you're seeing here in the middle is what we call a phenolic ring. So if you see that ring structure with the 3 stripes over here, then that tells you that this is a phenolic compound. And you might have spotted that in the vanilla compound as well. Aging in oak will always give you both flavors, so vanilla and cloves. There's subtle differences. If you're looking at French oak in specific, there's different species in France. And there's one that produces slightly higher levels of the cloves flavor, and that is the sessile oak. If you compare that with the other type of oak, which is commonly seen in France, which is the pedunculate oak, you're seeing slightly higher levels of the cloves flavor. Toasting makes a difference here as well. And the toasting process is often categorized in distinct levels, so low, medium, or high toast. This is not dissimilar to how you can categorize coffee beans as well, which often come like light, medium, high, or espresso toast. And cloves flavor you find more in a medium toast, whereas the vanilla flavor is more associated with a high toast. Now, these are small proportional differences. It's not an all or nothing thing. So as if you're getting all of the cloves in medium. It's not like that, but it is an effect that we consistently see between studies. Also probably more present on the palate. Yes, indeed. Medium toast casks are more popular for white wines than they are for red wines. For reds, you would often go for a slightly higher toast. So this is a flavor that you should especially watch out for when tasting white wines. I find it a lot in all sorts of oak age styles. So whether this is a Chardonnay or a Chenin Blanc or a Viura, for example, all grapes that are quite suited to oak maturation. This can, of course, indirectly give you a clue to what the grape variety is, not because the grape produces this by itself, but because some grape varieties are more suited to oak aging than others. Okay, I'll spend some more time on number 10, which is certainly an interesting smell. And we've arrived at the so-called tertiary flavors, and those are formed during bottle aging. So not from grape or fermentation or aging or secondary flavors, but this is a tertiary flavor. And petrol has also different descriptors. And many of them are petroleum related. Now, petroleum is a substance that we use to create a lot of different commercial products, of which petrol is one. But kerosene is also petroleum derived. So is diesel, and so is Vaseline, which is a petroleum jelly. And bitumen or asphalt is also petroleum derived. So this is a very unique smell that doesn't just smell of petrol, but can remind you of a range of petroleum-derived substances. Rubber is also a great call. It's very rubbery. Leather, I can see why people make that mention as well. Now, mothballs, there used to be an active substance in that, which is chemically related to what is in sample number 10. And mothballs used to have a compound called naphthalene added. And this petrol flavor is caused by something which is abbreviated to TDN, but is short for trimethyl dihydronaphthalene. So it's chemically related to the active substance in certain types of mothballs. So there you go. You have your justification why you could use the descriptor mothballs here. New books, wonderful. This indeed, if you think about a newly printed paper, whether that is new books or new newspaper or banknotes, it indeed releases the same smell. So probably a combination of the type of ink they use as well as the paper itself. Then tennis balls, like opening a tin of tennis balls, can give you that same smell. So useful to bring some nuance to the smell, especially because I think it's pretty interesting, complex, pleasant. The petrol descriptor itself doesn't necessarily do justice to how much of a appreciated flavor this really is. And I do ask during my in-person courses whether people enjoy what they're smelling in glass number 10. And then usually 3 out of 4 people will raise their hand and say, yeah, that smells really nice to me. And then 1 out of 4 is like, no, this is not for me. I don't think that this belongs in wine. So of course there is a subjective element there, but I feel that a lot of people appreciate this smell, and the smell of petrol itself, like the smell of a petrol station, is maybe not the most attractive. And I mean, you could also call this gasoline, of course. I think that's a bit more common in the US as a descriptor to use. Now, TDN, as mentioned, this belongs to this particular class of aromacomp isoprenoids. And this is formed during bottle aging of Riesling specific. So some very interesting things of note here. Riesling is really the only white grape variety where this has been identified in substantial amounts. And Riesling grapes don't smell of it. The juice doesn't smell of it. Even the wine after fermentation doesn't smell of petrol. So you do need a little bit of aging until this flavor appears. And a good rule of thumb is that it takes about 5 years for the flavor to appear. But that is connected to various factors. And the most consistent factor here is that of sunlight. So, and this is during grape ripening. So who would have thought that what happens in the vineyard is going to have an effect on what that wine tastes like 5 years later during bottle aging? Anyway, we see that greater exposure to sunlight results in greater potential petrol flavors in your wine. And I'll explain why this is. When grapes are exposed to sunlight, they can't tolerate too high levels of sunlight, and they need some form of protection against it. And that is not dissimilar to humans, right? If we are exposed to a lot of sunlight, we will start a tannin process, or we apply suntan lotion. And what the grapes do, they will produce certain color pigments. And these color pigments belong to the class of carotenoids, of which beta-carotene is the most famous one. And the more of these compounds build up, the more petrol flavor you're eventually going to get, because these slowly break down to form the petrol compounds. So those color pigments don't have any flavor by itself, but over time, over bottle aging, they will release the petrol flavor. And that is something that is connected to vine vigor as well. So the more rich the soil, or the more green growth you're going to get, the more shaded cover on the grapes, less sunlight exposure, and that means less of the petrol flavors. All of these things are connected. Bottle closure is another interesting effect. Screw cap has been shown to preserve more of the petrol flavor than natural corks do. In fact, natural corks can remove some of the petrol flavor in a process called sculpting. So it's basically absorbing some of the petrol flavor. And we know that it's unconnected to oxidation. So you might think, okay, well, a natural cork has certain oxygen transmission, but that doesn't really affect the petrol flavor. It's just simply an absorption process. So they've demonstrated it by having a large tank full of Riesling, and they thrown in some natural cork stoppers, and they indeed observed a lower level of the petrol flavor. So it's literally a reaction between the cork material and the petrol flavor, unconnected to oxidation. So when we look at real-world examples and how these effects come to be, Clark Valley Riesling and the similar style Eden Valley Riesling are famous regions in Australia for Riesling. And they are quite close to the equator. They're about 35 degrees latitude, which means that sunlight here is intense. You're going to get high levels here. And as a result, you're going to get more of those color pigments. And petrol flavor appears much faster in these styles. As little as 1 year in a bottle, and you will already notice that petrol flavor, it appears much faster, especially compared to the German Alsatian Riesling at like 49, 50 degrees latitude, further away from the equator, lower sunlight levels, and a much slower appearance of that petrol flavor. Okay. Something that appears more on the nose, not so much on the palate. It appears maybe a little bit weird in this sample because this is just a very neutral white wine with the petrol flavor, so it doesn't have the acidity that you'd expect in a Riesling, for example. So it may seem a bit out of context, but of course useful to smell it in isolation. In real-world examples, you might also see a bit of a honey flavor appearing at the same time from a component called phenyl acetaldehyde. It's an oxidation compound. And indeed, as Riesling ages, you're going to get other tertiary flavors there at the same time, not only the petrol flavor. So that will make it appear a little bit different than just here in isolation. So kind of unconnected to oxidation. Suppose you would have a Riesling in a tank for 5 years, you will also see the petrol flavor appearing. So it doesn't necessarily have to do with the bottle per se, but it's just something that needs time. It's a very slow process. It is facilitated by the acidity that Riesling has, and Riesling is one of the grape varieties that's known to have one of the higher acidities in wine. And that is part of the reason why you see the petrol flavor only appearing in Riesling wines and not in other wines. So it's both that Riesling produces higher levels of those color pigments, as well as having a higher acidity, which facilitates the release of that petrol flavor. Threshold being about 5 micrograms per liter. So we're pretty sensitive to this, but not quite in a range of nanograms. Okay. Now I'm wrapping up this presentation. The PowerPoint slides are available through my website. So if you access that website and go under the study materials, you can access the white wine flavors presentation file over there. This recording will be uploaded to YouTube as well. So if you're interested in rewatching this later at some point. If you have more questions about aroma compounds or wine faults, you can always drop me an email. More than happy to answer those. And I have weekly educative posts on my Instagram channel as well. So check that out if you haven't already. My full event calendar is also on my website. You can purchase the tasting kits via my online store. So you can either buy the wine aromas with the compounds pre-added, or you can buy the individual compounds, which look like those. And then you can use that using a pipette, which is provided inside your own wine. So that's another way of going about this. Maybe I'll see you in an in-person event at some point We've also just released the next webinar, which is about red wine flavor compounds, which will take place in September. So that is also present on that event calendar. I'll have a look in the chat if there's any questions. But for now, I don't see any questions. I'll remain online here for a little bit in case a question pops up. And other than that, thank you so much for your attention. Thank you so much for joining, and I hope to see you soon. Take care.